Hi, everyone. We will get started in just 1 minute. Hello, everyone, and welcome to today's webinar, where we'll be discussing how customers are delivering precision medicine with Tableau and Amazon Web Services. My name is Aaron Friedman, and I am our Healthcare and Life Sciences Technical Lead for the AWS Partner Network, and I'll be moderating today's webinar. I'm really pleased to be joined today by Andy Day, the Senior Global Industry Director for Healthcare and Life Sciences at Tableau, as well as Aaron Black, the Chief Data Officer at the Innova Translational Medicine Institute. Before we begin, I wanted to let you know that we will have time for Q&A at the end of the session. During today's talk, I invite you really to put any of the questions that you may have into the GoToWebinar questions window, and we will answer them following the completion of the presentation. Please note, that we may not get to all of the questions during the webinar, and in the event that we're not able to answer your question, someone will be following up with you after today's webinar. And with that said, there are really sort of several key learning objectives, themes that we hope you get out of the next hour. First and foremost is how customers are achieving precision medicine today using cloud-based visualization tools, data visualization tools. Second is understanding the methods for improving time to value with a dedicated healthcare analytics platform. And lastly, the real benefits of cloud-based analytics platforms for analyzing genomics data. And before we really dive in, I want to start by talking about the broader trends in healthcare. And the overarching theme in the industry that we're hearing today from hospital CEOs all the way down is the shift from volume-based care to value-based care is the biggest financial challenge today. And core to enabling this transition is increasing operational efficiency, deriving new insights for cheaper, and making sure that patients are getting the right treatment earlier on in their regimen. Emerging capabilities are rapidly accelerating the generation of these new data assets that are valuable to healthcare organizations, such as from clinical genomics, medical imaging, and electronic health records. And fortunately, at the same time that this data is exploding, compute power is continuing to increase at a similar rate, which really is making the possibility of computing on these new health data sets, whether genomics or et cetera, a reality. But of course, right, all of this really needs to be done securely. We are seeing a trend where a new healthcare organization is experiencing a security breach every day, so that really any type of analytics that we do needs to be done in a way that is protecting our patients, any sensitive data that we need to protect. And precision medicine, which we'll learn about today, is one such initiative really focused on driving the best outcomes for patients and enabling that volume to value based shift. And when we at AWS talk to our healthcare and life sciences customers about their data challenges, they mostly fall into the 6 buckets you can see on the screen. As I just mentioned, right, securing and protecting your data is job zero and really paramount when thinking in the context of protected health information, or PHI. And while security is an overarching theme, there are several other key components organizations focus on in their data strategy, right? They include, how do we acquire data from disparate sources? How do we store that data in a way that's meaningful for downstream consumption? How do we process that data in a way that's efficient and cost optimized? How do we analyze these data sets and visualize them to get new information about, say, a patient's treatment? And how can we distribute the data in a manner that has fine-grained access control with appropriate auditing and logging, as well as is easily consumed by stakeholders no matter where they may be? And in reality, these challenges are not specific to healthcare organizations. We hear about this across the board when we talk to customers, whether it's in healthcare or financial services, media and entertainment, or oil and gas. We really hear these same themes time and again. And that's really what we think about in the context of the data value chain. It's a set of common challenges and opportunities that our customers face with regards to their data strategy. And of course, right, we recognize that every industry is unique, but we can always learn from, say, a use case in financial services and repurpose that to better serve our healthcare and life sciences customers. But of course, zeroing in on healthcare and life sciences, when we talk to our customers in healthcare and life sciences, several themes emerge about what they're doing in the cloud and what they want to do, no matter the workload. And when we look across sort of the various subsegments of HCLS, whether it's claims data from payers, electronic health records and medical images from providers, genomics data, or medical device wearables, all organizations have a strategy around those themes of data security, acquisition, storage, processing, and analysis. And one of the really nice trends we're seeing in the industry is this integration theme, that whether it's this claims data or genomics data, organizations are integrating across data silos and breaking down those data silos to get a more holistic view of both patients as well as the populations they belong to. And in many ways, having a single pane of glass to visualize your analytics can also help accelerate discovery. In precision medicine in particular, precision medicine initiatives are leveraging these integrations and really going across data silos. And at its core, you can really think of precision medicine as what we see on the back of many of the coins in the U.S., e pluribus unum, out of many one. And the fundamental challenge or opportunity that we have is how we can inform the treatment of an individual based on the context of the individuals that or a population of individuals that are similar to them. And many of our customers are undertaking these endeavors today. And I'm really pleased to be joined by both Andy and Aaron to dive into some of ITMI's initiatives and how they're using Tableau to enable those opportunities. At this time, I'd like to hand it off to Andy of Tableau to sort of give an overview of Tableau's place within healthcare and precision medicine.
Hello. Can you hear me? Okay. Hi, I'm Andy Day. I'm the Senior Industry Director for Healthcare and Life Sciences at Tableau. Thank you, Aaron, for that warm introduction. So for those of you who may not know about Tableau, Tableau was founded as really started from a PhD thesis at Stanford Business School around 11 years ago, which culminated in a patent that led to really the development of Tableau as the analytics platform. So our mission statement from conception to this day remains fairly simple and intuitive, which is to help people see and understand their data. So building upon some of the trends that Aaron referred to, from a healthcare analytics perspective, clearly we see this transition from fee-for-service to value-based payments, which is, of course, made very daunting for many healthcare providers and payers because of the disconnected healthcare IT systems that abound. Having worked across 7 industries, it is my conclusion that healthcare has more IT systems than any other industry, which makes it particularly interesting and also challenging at the same time. And the implication impact is physicians, nurses, and clinicians have little to no access to the data needed. Again, this is based on customer feedback with C-level customers and that we talk to across the industry. So, what is needed to address this? Coordination of care across the healthcare value chain with data security. Very easy to put that on a PowerPoint slide, made very daunting, as Aaron pointed out earlier. So, what is needed? How do you even start to address this? An analytics platform to bridge this healthcare data divide is delivering value to a number of our industry leading customers. And obviously, the conclusion that, especially in the wake of healthcare reform, that physicians, nurses, and clinicians really need to understand their data without significant IT intervention. And unlike other industries, this is made even more mission critical because lives are at stake. So let's look at what our CXOs, if I can move the slide, yeah. What are CXOs looking at in terms of their priorities from a healthcare analytics perspective? This is based on some primary research from an Accenture study. A number of line items here, and I won't go through each of them in detail. No surprises that patient satisfaction, HCAP scores loom large, followed by healthcare system profitability. I've stratified it into the core line of business areas for easy interpretation. Next, of course, is low-hanging fruit in terms of operations, assets, and supply chain management, reducing patient wait times, length of stay, etc. And last but not the least, clinical population health, wellness, and disease management in terms of improving coordination across the care continuum, cost of treating chronic diseases, etc. So from our perspective, we refer to this as really enabling the data-driven healthcare enterprise with visual analytics. So we really help you see and understand your healthcare data with visual analytics for superior patient and population health outcomes. Here's a very simple schematic in terms of how we perceive the healthcare enterprise, clearly with the patient as at the center, and the core functions or lines of businesses that contribute value to the healthcare enterprise, going from strategic planning and human resource management, clinical patient and population health management, operations, procurement, assets and supply chain management, finance and revenue cycle management, and of course, enterprise IT, which brings all of this data, aggregates the data, cleanses the data across electronic health records, ERPs, revenue cycle management systems, etc., and then provides it in a form where it can be meaningfully analyzed to deliver value across all these functions. What does that mean? I'm sorry if I can go back. Yes. Can you go back? One. Okay. So those are the core use cases where many of our customers have seen value, from targeting the most promising segments and markets and where do they locate their next healthcare facility in a strategic planning concept to, of course, quality and safety, population health segmentation and risk stratification in a clinical patient and population health management context, enhancing emergency department OR and ICU asset utilization to strategic sourcing, procurement, and inventory management in a supply chain context, and of course, accounts receivable, collections, planning, budgeting, forecasting, denials management, finance and revenue cycle management. Won't go through those details, but where have customers seen value? So on this x-axis here, we have some of those lines of businesses that we alluded to in the previous slide. On the y-axis is the realized value that they have actually documented and communicated via their presentations at our conferences and multiple webinars, which would be more than happy to share with you. So quick look at some of the use cases and success stories here. Piedmont Healthcare, 6-hospital system from Atlanta, started with really a hospital performance dashboard that replaced about 2,200 Excel spreadsheets that they were using for the process. 23% improvement in IT productivity, delivering $650,000 in savings. They looked at cardiovascular department physician scheduling, which was the largest contributor to their revenues, $2 million in savings from better scheduling their physicians. Uh, Extended that to labor department productivity, obviously the largest line item and expense in terms of a healthcare enterprise. 70% of the cost of running a healthcare enterprise is labor department productivity. $10 million in savings per month from overtime and agency cost. Massachusetts General Hospital, laser focus on hospital-acquired infections, specifically CAUTI and CLABSI, reduced CAUTI by about 85% in 1 year with about $14 million in compliance-related fines and penalty savings over 3 years. University of Michigan Health Systems, $3 million in savings from their audits, as well as about 6,000 labor hours saved from all of the automation they accomplished through their visual analytics deployment. A cardiovascular emergency department physician at Mount Sinai, really playing with their denials management data. After hours, identified about $125 million in suboptimal denials management, which even the CFO's office had not seen. And from an inventory and supply chain management, Seattle Children, saving about $10 million per year. And probably the most significant story we have seen is Barnes Jewish Hospital, one of the largest hospitals in the Midwest, saving almost $212 million over a 3-year period from strategic sourcing and procurement through their spend analytics. So with that brief overview, it is my privilege to turn this presentation over to Aaron Black, who I'm very honored to also call my friend, to articulate the path-breaking work on precision medicine that he and his team have led at the Innova Translation Medicine Institute. Aaron, all yours.
Thank you, Andy. Thank you, Aaron, for those great introductions. I think it leads in very well to what I'm going to talk about today. So again, my name is Aaron Black. I am the Chief Data Officer for the Innova Translational Medicine Institute. And today, let's make sure my presentation works, and I can move through the presentation. But what I'm going to talk about today is about our institute, about Innova. I won't go into much detail there. But what I'm going to then talk about is why Innova is investing in translational medicine, and why they're investing in my group and my team and the talented researchers and scientists and clinicians that are part of our group. But this has been a journey, and it's been one that we've learned a lot. So if you're at the beginning of your journey when it comes to translational or precision medicine, if you might be farther ahead than us, but really just to tell a story so that I think one of the big movements is, us sharing as much as possible, because this is a very hard thing to do. And the last component is to look at the results in summary. So just summarize what our journey has been like and what we've learned. So about Innova really quickly, we're located in Northern Virginia, just outside of Washington, D.C., the nation's capital. Comprehensive healthcare system, 5 major hospitals around the region. If you want to look us up, it's innova.org. You can get some more detail about us, but we are a large integrated healthcare system, but we are non-academic. We are based in the community. And then our Translational Medicine Institute, where my team is and where we are going to talk about today, was founded way back in 2011. I've been at Innova for just about 5 years exactly. And over those 5 years, we've realized and are continuing to realize that vision of taking this information, particularly around genetics and genomics, and applying it to our patients and our patient populations. So we have seen the growth of this industry. We have seen places and people and software and technology like Amazon, like Tableau, that have helped us along this journey. About just a couple things about our research. So I'm not going to read through these bullet point by bullet point, but again, we've been around for about 7 years, and we've accumulated a lot of data, a lot of very large data, whole genomes, epigenetics. We collect and biobank a lot of samples that are used in our current analysis as well as future analysis. We collect clinical data both on patient engagement surveys, abstraction from the EMR, and now direct data feeds from the EMR as well. So over the past 5 years, we have got large data, we've got messy data, and the team has had to go through this journey to put some context around that so we can use it for our research. So why did the Innova Health System invest in it? And that's a question that, when I came here, and actually the reason I moved in from Ohio to Inova was that they believed in this and they wanted to give back. And there's a couple different stories here to tell. One is of this macro population that we're, healthcare in the United States is in the midst of kind of a tipping point. And this visual I like, and this is from the Institute of Medicine. They did some polling on the United States against other like countries with a similar kind of profile as us, so the same economic profile. And what you can see very, very easy here is that one, at the rank, the number one countries were not the United States, as people grew from 0 to about 60 to 70. So the United States is one of the worst, if not the worst in the world when it comes to keeping our patients healthy. However, if you make it into your 70s, the United States is really good at keeping you alive. And so you can see that steep curve. And I think that's a fundamental aspect of our health systems, is that, we're concentrating a lot of our work at the end, and we're not keeping our populations healthy as we move throughout life. And so this is something that has hit me personally. And this picture is one of healthcare records. So this is my wife, her healthcare records, and that ginger ale is just for reference, even though that is her favorite drink. And I show this is about a year and a half old, so this has actually grown quite a bit. She has been on a diagnostic odyssey for the past, let's say 7 or 8 years, has moved from healthcare institution to healthcare institution, as we have moved from the Midwest to the East Coast, and now we're actually going back to the Midwest for some specialists. This is still the way we exchange healthcare data in a lot of context. So for me, as a personal mission or personal thing that gets me up in the morning, is to see that this goes away, to see that we can use data in a way that can actually improve our healthcare as we are in our 20s, our 30s, or our 40s, so that we do make it to the end of life, and we have a quality of life that is, worth living. But the reality here is, in living this for the past 9 years within healthcare, specifically here at Inova, is that this, even though the technology is great, a lot of the things in branding that you see is still very hard to do. And one of the things about this, especially when you move this into the clinic, is it's still operationally expensive to implement precision medicine programs. And I think there's a lot of a room for growth there. But that's, again, why I do these presentations, because there's other people out there that are doing this very well. And Inova has learned a lot of lessons in our experience. The other issue is that healthcare in general is pretty risk averse. So, innovation is a word that we use quite a bit, especially recently, but it's to implement that, to make sure that we're, protecting our patients, protecting our data, is very, very important. Talent, just because you collect a lot of data, just because you have sophisticated sequencers, doesn't mean that you can do things with it. So one of the things is, making sure that we have enough talent to do the work that we need to do. And the last two, immature data standards, particularly when it comes to genetics and genomics, when you're trying to apply this into a clinical system, it's pretty raw right now. And even in standards that we see, for, your HL7s, your LOINCs, your ICD coding, it's still immature when it comes to some of the newer technologies that are out there. And so all those 4 kind of bullet points really point to, is there unrealistic expectations for a healthcare system to implement these types of things? How can we do this in a way that does match those expectations? And so that moves us into this journey that I'm going to go through the rest of this presentation. And it has to do with what we've had to build, what we've had to do at the Translational Medicine Institute here at Inova. And at a very raw level, because there's a lot of sophisticated architecture that has to go into this, and there's other presentations that we've given that we'll get into that detail, but really we're at this kind of inroads of what's the reality of what we're doing. We're spending lots and lots of money to take data in, but we're always asking for more. So we get this really thin sliver of a Venn diagram of what we have and what we need. And if there's data that we're collecting and that we're not really doing anything with, particularly when it gets to the scale of genomics, imaging, terabytes, tens of terabytes, petabytes, we're wasting a lot of things because we're towing it, and we're spending a lot of money to collect it. And so really, to me, when we talk to the accountants, this is uncollectible debt. When we look at the data that we need and we can't get to it, it's really wasted potential, because we should be able to get that data, put it together, and it's an opportunity cost. So we're spending a lot more money, basically capturing things we don't use, and we should be using it to collect data that we need, because ultimately we want those two things to push together, this Venn diagram, to produce the knowledge and the information that we're going to need to disseminate across our populations, across our healthcare providers, to really truly make a dent in that curve that you saw very early on with the Institutes of Medicine graph. So what we've tried to build here, and the story that we're trying to tell, is that there's methodologies that the clinical systems already use, and one of the lessons we've learned, and it'll come out at the end, is that we're trying to leverage the platforms, all the infrastructure that the IT systems have already leveraged, but we see it in a different way. We want to consume that data a little bit differently. So if you're looking left to right, we want to get the sources, we want to put it, and I use the word data lake because that seems to be something that people gravitate towards, so whatever you call that. We want to process it, we want to do quality control on it, we want to put it into an EDW. We would like to enrich it with our own data or with other people's data to make it better. And then we produce, for lack of a better term, a mart that they can be consumed by, the clinical systems, we'll call it business intelligence. When we're on the research side, we call that, the new term is called data science. But we're still going through that same methodology, whether we're dealing with clinical excellence or we're dealing with, really more discovery and innovation. However, it gets messier when we, try to make sure that we're, having the talent, having the tools to match what each environment is really built to do. So for clinical and operational analytics, you're looking for more certainty. You have patients that need care. They're depending on you to do a good job, so they stay healthy, they stay alive. On the research informatics side, we want to grab data from the clinical systems, and this Honest Broker allows us to do that for our IRB controlled studies. But we need to iterate quite a bit faster because we need to learn, and we need to learn quicker, and we can't necessarily go through a methodical process when even our funding mechanisms are different with grants and contracts as opposed to 5-year budgets that are based on a 2020 vision or a strategy that the health system is implementing. So that's where we've learned a lot of lessons, is how to have a symbiotic relationship with the clinical enterprise, but also establish a culture of innovation and discovery. So we've kind of bulleted this down to 6 points here, and I'm not going to go through the bullets. You can this will probably be available after we leave. But we came up with when we get acquisition of data, what do we do in order to learn to optimize and give this back to the clinical providers, to the patients, so they can improve their lives, improve the care. And so we look to acquire the best data, and we'd like to do that in a consistent way. We want to make it usable. So just because you collect something on a Fitbit or some kind of telemetry or a genetic sequence, we have to make it usable for the people that need to use it. We would like to give it to the most people. There's a security context around this, but it has to be a process that's governed by both the clinical systems and the researchers who are using this data. We want to use precision tools, and again, that's why a lot of you are on this webinar, to use precision tools that Amazon, Tableau, and others can provide. We want to measure all this because there is a return on investment here, and we have to understand what the technology, what the teams, what the processes are costing us so that we can optimize, learn, and start to predict and use this data in a way that can go not just in a translational medicine institute like ours, but to the greater population that we serve. And so this journey, this is a graph that we've seen in various places, where at the left is where we start out typically. And when I came here 5 years ago, we started in this area of data silo, where thing was everywhere, even within our own institute. And many of you probably have this type of experience, whether you're at now or where you're going. But as we move left to right, we're looking to get to that point where we can start to process things more efficiently, to enrich our data sets, to start to predict and prescribe, as opposed to being kind of very reactionary. But that is a level of effort to get up and going. And so getting the data out of the silos takes a lot of effort. And then when you get to the enrichment, prediction, prescription component, the level of effort goes up highly as well. And where we're at now within our institute, we're a little microcosm because we get all kinds of data from different components of our health system, is that we really want to get to the point where right now we think we're doing 30% of the work is analytics, and 70% of it is just wrangling the data and that blocking and tackling that happens to get things done. But where we want to get to and what we're pushing forward to is this 80-20 rule. We'll never get out of the data management business. That's what we do. There's always going to be new data sets, but we want to start to flip this on its side. And so there's a lot of visualizations that we've done in order to tell people how hard this is, but also give them the vision that we do have a strategy to get to the end. but sometimes those pictures don't make a lot of sense, and they gravitate more towards, we're data hoarding. We're just like that, those videos that you see where people hoard their information, and they know where things are at, but nobody else does. And so we're moving towards this more concept of we can expand and actually have rooms much bigger and broader than what you would stuff into your closet or into your living room, but we need to catalog it. We need to put it there in a way where more than just one individual knows where things are at. So that's been our methodology. Now, when it comes to the technology and what we use, we think of this as a data funnel. A lot of our larger data sets are captured in AWS. We have a lot of third-party vendors that generate a lot of our larger data systems. So when we acquire data, I think we're closer to around 3 petabytes right now, but 97% of that is genetics and genomics. But we collect it, and as it moves down, we again do that discovery, that cataloging. We want to know where things are at. We then want to model and integrate it and enrich it, so people, this is where metadata standards and other things allow us to take large amounts of data and then funnel it down to where people know what it is. They can do quality control, and we use Tableau in this respect on top of Microsoft SQL Server, and we have various different types of data stores that we use, not just Microsoft, but that's the one where we do a lot of that discovery and annotation. And then we start to optimize. So then this is where those iterations come in that you saw in the previous graph, of constantly going back, even back to sources, and iterating through so that we can optimize it. And we've used Hadoop when we get to the point where we want to do some of the bigger data analytics surrounding that with Python, R, Spark, Perl. A lot of the bioinformaticists love the open source tools. Our data science brethren love the open source tools, love the scripting languages. So we provide that as a service. And what we come down to is, even when we're dealing with about 2.5 petabytes of source data, we can whittle that down and optimize that to about 25 terabytes. And then in the Hadoop world, we have, we store that 3 times, and again, for performance. So it ends up being about 3% of the total on disk. So that's how we've tackled data processing to get it to our consumers. And I just put down there at the bottom for our initial run on the Hadoop side, we had about 7.3 trillion data points that we were tracking. So it can scale quite large. But again, a lot of people only using little small tidbits of that data. So this last part of my slides are going to go through that kind of methodology, how we've used Tableau, how we've used Amazon to acquire the best data, to make it usable, to distribute that through others, and we're going to show some of the actual visuals that we've done. And so the first step is we want to acquire the best data, which, a lot of times we acquire things we can measure easily. So genetics and genomics are things that we've established we can measure at a very, very small molecular level. But once we get it on disk, we want to make sure we've got the right data, so that when we do give this to the bioinformaticists and the analysts, that they have the best. And what we did really early on was a visual like this, very simplistic. We went to AWS where all objects were at. These are just object stores in S3. We said, how big are those files? So across the bottom, we get genomes are actually packages of files. They're not just one file. So we said, how many files are we getting and how big are they? And we used to have 2 different types of sequencing. We've been around so long that there was a precursor to Illumina, for those of you who are in the sequencing world, and Illumina is the whole genome sequencer of choice. Complete Genomics was our original, and you can see in the orange, that's the Complete Genomics. You can see it's all over the board, very inconsistent. And in the blue, you see the Illumina genomes, very consistent. But you also see 2 kind of humps there where they're kind of overlapping. And what we found was Illumina at that point in time was depositing this data directly on S3, and it had done a handful of genomes twice. So we were actually getting double the size, double the files for a handful of genomes, and this was a very easy visual for us to figure out that quality, and that we were getting the best data. So when we do our analysis downstream, saved us a lot of money too. So that was on the bigger data side. And then when we look at the electronic health record, so we initially we track our patients longitudinally. We have consents where we can track patients as they come in and out of our healthcare system, just to see if they're if they're having interesting things happen to them. So this is a trend chart in Tableau that looks at our patients coming in the door. So we have I think right now it's 4,500 families that we track. And what we saw when we initially put this in here, you can see the encounters that we're getting in the health record. You can see that huge spike that happened right around October 12th or October of 2012. That would happen to be a year before I got here to Innova. And what we found out was this is when Innova went live on Epic. almost exactly to the date. So you can see that the EMR was actually in just a couple of the different inpatient places, and so when they went to the more integrated EMR, the data started to explode. So we were starting to look at trends and patterns, and this was a great way for us to look at how the health record was exploding. That data is constantly changing, where a genome is fairly static when we receive it. So that was pre-EMR. So we collected it, we find the best data that we want to grab. Now we got to make it usable. And again, we used a lot of data governance around this. So the data comes in, now we need to codify it in a way that makes sense to people, that's consistent. We do 12 studies. Not everybody calls things the same way, at a very low level too. I mean, we were surprised at the variability that we'd see across studies. So we came in and we created a data dictionary on top of all our studies. We came to a commonality, what we called them, how we wanted to layer them to make the resource more valuable. And so we saw a lot of savings both in analyst time and in the way that we did quality control that was very consistent. And we could do that again with one visual, and we modeled the data and iterated through quite a bit, and Tableau gave us a great way to do that. So it saved us a lot of time. The other thing it allowed us to do is to look at our longitudinal studies in a way that was very interesting to us. A lot of this data we at the health system had never seen before when it came to these studies. And so we started to, again, model around this data. We started to look at trends, before pregnancy, during pregnancy, after pregnancy. What types of diagnosis were they coming in with? Were children starting to come in with broken bones in a certain area? And then we can go back to the genetics and look and see if there's anything that would be at least a correlation that we could begin to deeper dive into, again, with all this data available to us. So again, we were able to start to pinpoint patterns in data that we weren't able to do with spreadsheets and other types of analysis tools that we're using. And that really where we get into the tools. So now we've got the data, we think it's usable, people are now interacting with it. Now we started to use Tableau in other ways. And so this is a list of all the genomes and all the subjects that we have in different countries. And so we started to see that we're an international area, being close to DC. A lot of these people were born in countries that were not the United States. So the darker the color, the more people we had in these different countries. And so again, a 10-minute visualization in Tableau allowed us to kind of see, hey, we're very unique in a lot of ways when it comes to our population, and we should maybe look at these different areas to find interesting ways that we can analyze it. We also looked at geography at even a more detailed level. And so this is where our people actually physically were coming from, meaning our research was definitely in the Northern Virginia area. You can see Washington, D.C., but we started to say, not only do we want to look at their genetics, but where are they moving to? Are they moving to other areas? Can we keep track of them? Are they going to continue to fill out surveys? So even from an operational side of research, it was very interesting to us. And so what we saw after 3 years is that, yeah, people were moving all over the country. They were, coming back to us and telling us about the updates of their address. But when we're trying to do maybe some environmental studies, and ANOVA has won an ECHO grant from the NIH to start talking about environmental data. So we're now starting to get into geolocation, where people are moving to, how close they are, how close they are to particular known areas that might have bad air. So it really gave us a way to start to look at other ways to utilize our data to become part of other consortium. Then finally, what we're all kind of looking for is this predict and optimize. And so another area that I didn't highlight early on, but is of note, is that our group also supports, our group here at ITMI also supports a clinical genetic testing lab. And one of the key linchpins of that is a tool that we've branded MediMap. And so this is pharmacogenomic testing, which is where we are looking at specific variants of interest, and these are all FDA approved variants, and we look to test them and look at the drugs that could be impacted, and we're able to return those results back to patients. And this started about 2.5 years ago, and you can see this is again all on the website if you want to dig into the different drugs, the different variants that we look at. But it ends up being quite interesting to us, both at how we can help patients improve again the way they're treated, but then also look at this from a research angle. So secondary use, looking at ways that, and this one is kind of a different way that researchers look at data. So you look at this and it's very interesting, aesthetically pleasing. Again, this is done in Tableau with the genes. the races and the way that these individual patterns of data kind of look. But when you look at what the other views that people like, so this more population view, and so we're able to do this also in Tableau. So the great thing about these tools now is that you can actually have different visualizations for different types of end users who have different distinct needs. And so this one, we have this green, yellow, red, very much a stoplight thing. So these are the drugs that we're looking at, the populations that that we look at, and how many of those are coming up green, red, yellow. You know, red being they're not going to have a good reaction to this, or the drug will not be effective for them. Green means they're just just like a typical population for the drug, and then yellow is more of a maybe a variant of unknown significance, a variant that there is literature on it, but it might not be something that is 100%. The way they say that gene's the cause. So this is the interesting thing that we get into is looking at that same pattern of data, but now optimizing it for different types of views. And then the one that everybody, back to the detailed view. So then this is individual test results, the individual drugs. And I know I've had mine done. I've had family members get their sequencing done, and they are very interesting. And you start to see stratifications in populations. So we're playing even a middle ground now where we're doing precise tools and predicting, adverse reactions to drugs. But now we're also being able to collect that detailed information in a population to start to see ways that we can improve those people. So to wrap up, we're trying to provide these types of analytics to the most people. And one of the things that we've looked at quite a bit, and part of my job now as Chief Data Officer, is to look at a lot of technologies that enable us to do the research. And the reason I'm on this call today and in this webinar is to really help people as they're looking to pick which technologies to use to open this thing up. And AWS has been a partner now for over 5 years. I think Tableau has been a partner for more than 3 years for us. We've expanded a lot of our capability to the clinical systems for both these technologies. And in order for us to really make this usable for others, we have to find the right tools and technologies that allow us to rapidly ingest data, to optimize it, to secure it, and then to give it to the people who can do the best with it and the most with it. And those are really the talented people, the researchers, the clinicians, the nurses that allow this to be optimized within our healthcare system. So my last slide really is the summary, and that is what we've seen in this odyssey of 5 years, and what we've learned, and what we want to continue to do. And it is a big part of what we want to do here. And I think it's, again, back to the graph of treatments and how costly they can be. We want to start to use this to keep people healthy, not to wait till the end of life or to when they really need the services. We would love to keep them healthy and happy and outside the actual hospital itself. But it is still maturing. It's still expensive. Genetics, these numbers have gone down, but that just means you're doing more of it. And that means the data management part of it becomes a little bit more expensive. And the market's still maturing. But our team, and my team, is in the Q&A. If you want to know more about our team, we support the full data lifecycle here, and a lot of our work has been around literacy. So we are educating researchers, we're educating the data entry folks on how to do things as consistent as possible, because that's really what's going to revolutionize this data. If it's not usable from the outset, we're losing value. So we've done a lot of work in data literacy. The consistent and targeted use of technology, actually finding operational metrics that says this technology works for us, because there's a lot of great technology out there. We have done a lot of savings now because we're collecting the right data. We're not just massively just trying to collect everything. We've been able to target what we need and how to optimize that and how to eliminate double entry. Instead of having to do this in a spreadsheet on the side, we're actually now educating our end users on how to change the interfaces to collect data. And we want to make this repeatable. So not just for our institute, but our new work is now moving into heart and cardiovascular, into cancer, to others who can use precision medicine to support our patient population. And we really believe that the use of the tools, the technologies, the process, the talented people will allow us to expand our capabilities in precision medicine at Inova. So with that, I am done with the presentation part of this. I'm going to hand this back over to Aaron, who will wrap it up and then also open it up to Q&A. Aaron?
Great. Thank you so much, Andy and Aaron, for an excellent, real overview of both Tableau in general, but really I've been in precision medicine in my past before I came to AWS, and this is really an incredible example of how it's being practiced today. With that, I want to transition into the Q&A. Looking at the time, we do have about somewhere between 5 to 10 minutes for questions before we close. So I want to start with one question that came in near the end. Aaron, I know you mentioned that you've been working with AWS for 5 years, Tableau for several years. Can you expand a little bit about how your use of Tableau has evolved over the last 3 years since you first started working together?
Yeah, I will say that it started more again in that raw visualization stage, meaning we was more our user base has changed. I think that's maybe the thought here is that our user base changed from people who were really good with data, they knew SQL, they knew best standards for data, bringing data into a visualization tool like that, and is now kind of transposed into where we're now educating our users on the data literacy components, and we're actually giving them the tool right now we use Tableau Server to start to do some of the self-serve. So we will prepare data for them, but we can now sit in a room, engage with them, and then they can take it back with them and start to do those iterations, those optimizations without us having to be over their shoulder, which is tremendously powerful. And we do believe that by doing that across not just our institute but other institutes and within the healthcare system will truly revolutionize the way that we use data at Innova.
Excellent. And with regards to using data, there is a follow-up question around the lines of how you're really, leveraging Hadoop within Innova. And sort of, it would be great if you could spend maybe a minute just sort of walking down that path of how the data visualization that you get in Tableau feeds into that end of that funnel, if you will, right, that you showed with Spark and Python and R and Perl, et cetera. But maybe just walking through, if you'd have a second to sort of walk through that overall process in a little more detail.
Yeah, so there are some presentations out there where I do walk through through AWS, but if you can understand that we consent patients in the EMR, that really kicks it off. We do your traditional kind of data warehousing within a SQL server that says the patient consented and this is what they did. As we add, EDC or electronic data capture data, that starts to happen. We collect biospecimens that go into a Oracle system, laboratory information system, and again, we nightly put that into a more traditional warehousing package. That data then gets routed up. We create views, so kind of think of the data mart, and that gets moved up to AWS. So they think flat files, so nothing glorious here. I mean, a lot of this is blocking and tackling, but we move that up to AWS. We put it in Redshift, which is the columnar store. It's probably overkill, but it's a compliant system on the security end. And then we use Tableau Server to visualize that data. And so that helps us with the beginning of the funnel, because what ends up happening with those biospecimens is we do produce genomic and epigenetic, and now we're doing microbiome data, and they come in as flat files. So we need to make sure that we're matching all those up. And then once we've matched them up, that's where Hadoop comes in, because we don't want to bring in data into that Hadoop world until we know the person, we know they consented, we know that the genome is structurally intact. Then we build a Python. Think of this as a data pipeline in Python. It's open source bioinformatic work that brings those genomics in a Parquet format. Again, not for this discussion, but a very detailed bioinformatics work that was done with a group out of Seattle to bring it into the Hadoop cluster in Parquet files. And that's what we use to visualize the genomics, which our bioinformaticists use with the Perl and now Spark heavily, because Spark is great for in-memory, more interactive Hadoop as opposed to Hadoop, which is built more for batch.
Excellent. So one of the questions, Andy, this is more geared for you, and it's asking, so obviously our data sets are multivariate, they come from disparate sources. If a data set has several attributes and I want to cluster data, what's really the best way to visualize that kind of data in Tableau, and what are other healthcare and life sciences customers doing?
Yeah, so we have obviously a number of clustering capabilities built into the platform, and that we are building upon. I think in addition to that, in addition to obviously working with Tableau as your self-service visual analytics platform, one of the things we have done as part of our strategy is also to work with an ecosystem of strategic partners to deliver package solutions specifically for healthcare and life sciences use cases, right? For instance, we're working with Amazon on a HIPAA compliant, cloud solution that hopefully we'll hear about in the foreseeable future. We have, solutions for everything from population health segmentation, community health risk assessment, population risk stratification, inventory management, strategic sourcing, spend analytics, etc., which a number of our strategic, partners have built out for us. And we'll be happy to discuss those with you, understand your specific needs, and show you best practices in terms of how other customers have done it. Or if you choose to, if this is aligned with your strategy, we can point you to a partner who can deliver a package solutions to meet your needs and really time to value in very rapidly in 80 to 90 days or less.
Excellent. And with one of the other questions that came up a couple times is how do you distribute the dashboards? Can you walk through that process? Just quickly how you can share grant access, revoke access, et cetera, to different dashboards.
I'm probably not the best person to talk about it, but it's fundamentally done via, Tableau server, and which obviously has significant security capabilities built in. Perhaps Adam, you can add and talk about how you're doing it at ITMI, right? Ensuring that literally the right person in the right role has access to perhaps the entire workbook or sections of the workbook with row level security built in. But that is something again we can get into details around if you reach out to us.
Really quickly, the role-based access, as Andy said, way we've tackled it is definitely. I only had one slide on this, the data governance around, what data they're asking for. We give them, the ability to specify what they're looking for. We create project teams around building those with them, and then we can give access to those reports via more of a browser type of feel. And we can also have them subscribe to have the distribution. So every Monday we can say, hey, you're going to get this Tableau report in your email, and if you click on it, it's going to go to the Tableau server and allow you to log in. And so it's very similar to other apps that you would have as far as granting access, revoking access, and allowing them to do some things within the Tableau interface to build their own reports, download, and other more sophisticated data management concepts.
Excellent. Thanks, Aaron and Andy. With that, I recognize we have a ton of questions, but unfortunately we're going to need to close out the webinar in a second. To answer one that a lot of people asked, we will be distributing a copy of the webinar following today's presentation, so please keep an eye out for that. I know a lot of people asked for that in particular. For the questions we weren't able to get to today, every question is valuable, and we will be following up personally. One of us or one of the individuals we work with will be following up in the upcoming days or week or so. But with that, I do want to just really quickly close with a couple slides, just with regards to further information and whether you can grab these links right now or in the follow-up to today's webinar. Please feel free to explore more on the capabilities that Tableau is providing for healthcare and life sciences. I do know that a lot of our customers are realizing some excellent utility with Tableau's self-service visual analytics platform. And what's really exciting is what Aaron described today is phenomenal, but it's not happening in a vacuum, right? It's not just ITMI that is achieving these outcomes. And we're really excited to be working with Tableau as a really valued partner to advance the analytics capabilities of our healthcare and life sciences customers. And on the last slide, there are a couple events coming up that, Andy, I know you wanted to touch on for a very brief minute, and we hope to see you there. But Andy, I'll hand it off to you.
Sure. Thanks, Aaron. Again, really reciprocate the spirit in terms of how valuable our partnership with AWS is. So we look forward to really seeing all of you at our annual Tableau conference. We refer to it as TC18, which is happening from the 22nd to the 25th of October in New Orleans, where we anticipate actually almost 20,000 customers this year, and we're very excited. AWS reInvent is another huge opportunity for us to engage, for you to engage with both Tableau and AWS, happening from the 26th to the 30th of November in Las Vegas. And again, to my earlier comments, if you have immediate needs or questions in terms of how Tableau can deliver value similar to some of the value from our other customers, which I showed on that slide, please feel free to use this email to contact us, and I can assure you, you'll receive a very, very prompt response. So again, I'd like to thank Aaron Black and Aaron Friedman for a really compelling presentation, and all of you in the audience for really investing your valuable time in listening to us, and hope this was very, very worthwhile for you. Thank you.
And thank you everyone again for joining. As a reminder, we will be sending out a copy of today's webinar following the presentation, so keep an eye out on your email for the next several days. And if you have any additional questions, you can also use that email that is displayed on the screen, and we can help direct you to the right resource to help you get up and running quite quickly. And with that, we will be closing out today's webinar, and hope everyone has a wonderful day or evening, no matter where in the world you may be. Take care.